Hello. Today we're going to talk about multi-cloud VMs and a single control plane, OpenShift virtualization with Advanced Cluster Manager, and how that can bring the ability for you, your organization, and your engineering teams to be able to deliver a multi-cloud environment with a single pane of glass view, and that ability to move between on-prem and your hyperscalers of choice. What we're going to talk about today, why VMs still matter, the cloud drivers and economics behind these things, Kubernetes native virtualization, where we are, where it's going, portability, and the open hybrid cloud, and why multi-cloud virtualization should be your choice right now. We'll jump into a demo. Currently, companies need to preserve their VMs. There's a lot of commercial off-the-shelf software out there that can only run within virtualized environments or on operating systems. There's a number of legacy applications that organizations still require, that these suppliers have either gone bust, disappeared, or even refused to move to containers for whatever reason. As you can see, the segregation, the split here of bare metal, VM, and container. And while we're seeing that container is slowly creeping up, there is still an incredibly large level of virtual machines. And I suspect any of you, if you dig into your organizations, will find that there are a number of VMs either sat on-prem or somewhere in your hyperscaler running on a virtualized instance there. There's an opportunity out there for you to be able to address the issues you have, and potentially you have an incumbent virtualization provider that's causing problems. But you could match that with a very similar interface, a way to overcommit your VMs, just like you have done, just like you will have done for a long time, but start that journey to modernization by running your virtual machines within an environment that accepts VMs as much as it accepts containers. Why should you consider running VMs in the cloud? A lot of organizations are talking about data center exits. They're looking to remove the burden of having to buy their own hardware. And as we know at this moment in time with the AI pressures, it's very difficult to actually renew kit. There are 6 to 12 month wait times, according to some of the customers that we speak to. Scale to the cloud, that ability and what the cloud was built for, the ability for you to right size your environment at the right time, be that scale up, scale down, depending upon the workloads that are happening or the users that are consuming your services via the web. Application modernization. There is a move. There is a move to be more cloud native. There is a move to containers, but that doesn't mean you can do that with every single application that you've currently got. Over provisioning and sprawl, major sources of cloud waste. We constantly have conversations as specialists with organizations where there is a complaint about their cloud bill, and there's a lot of effort that teams put into being able to right size the virtual machines they use, being able to make sure that things are scaling up and down. But then they also need, you have a committed spend agreement, you need to cover that kind of up. But also then forecasting your spending. FinOps is a massive thing, and most organizations are picking up the value that can bring. And that's all the top 3 that are there. And utilizing managed services, managed OpenShift in the cloud with your VMs can help you align with all of this, reduce your waste of underutilization of your VMs, optimize your workloads, the overcommit, utilizing the bare metal nodes they got, still while committing against your spend for your hyperscaler, but also being able to reduce far more accurate spending, but also labeling up. So you can cross-charge the departments that you need. All of these things, I suspect, you're asking your engineering teams and your managers to be able to provide you the information with. What's leading to your overspend? We, recently through a lot of the Virt migration that we've done, we've realized how despite the levels of optimization organizations have put in, there is still a huge underutilization of their virtual instances. But then there's a lack of individual team responsibility, sprawl, a lot of things that come down to the way engineers behave, which is already built into OpenShift, be that cloud or virtualization. But with virtualization, you can bring that over provisioning that you were used to previously. How busy are your virtual machines? And here's some times here of the amount of hours that go into in a year. And are your machines being used to the best of their capability for all of those hours that they need to be? Averages, yeah. And this is not stuff that we've just made up. This is where we've actually gone out and spoken to customers. Shared capacity, scheduling and all of that. But if you have a look here, that it becomes very, very expensive if you are not utilizing your instances to their full capability. And the bigger the organizations and the more services you have, obviously the more opportunity there is for you to save large quantities of money. But if you have a look, let's just take manufacturing. The low levels of utilization there that maybe OpenShift virtualization could help them with. Optimizing your strategy. Large footprint of VMs. There are many organizations running multiple VMs all at the same time because they've got across different environments, often into the hundreds, often into the thousands with recent conversations that we've had. But this is kind of growing the cloud spend, and no matter how much you squeeze down your VMs, it's very difficult to get the full optimization out of them. So that starts then to increase the cost per VM as the estate grows and line items become excessive. But also the push for the data center exits. A lot of data center exits have landed organizations to just using EC2 instance because there's a sudden need to get out of there. But then there's also a modernization push. And for a lot of orgs and a lot of, I suspect, your organizations and your teams, you are asking your engineering teams to also deliver on modernization while they're still supporting old virtual machines. And it's how can you align the two so that you most efficiently deliver what the organization needs at the right value. Opportunity, high density virtualization. Like we say, we talk about the fact that people are lifting and shifting out of their on-prem data centers and into the cloud. And that kind of removes the ability to overcommit that you might have been accustomed to with your hypervisor on-prem. But here we have a shared platform capacity. You don't treat every VM as an isolated incident. It sits on top of a cluster, and you can overcommit. You can overcommit your memory. You can overcommit your CPU. You can control the way that is done, allowing the workloads that need that breathing space to be able to do it, but also then allowing much more freedom in your pre-production environments, for example, where that ability to much more greatly overcommit is not going to affect the end customer. And what does that mean? That means that you can run your existing and potentially new VM workloads more efficiently, utilizing tools that are native within a Kubernetes environment, within OpenShift itself, to actually squeeze things better together, to right size your cluster and to right size the number of VMs that are running on there. This is not new. This is not new to Red Hat. This is certainly not new to OpenShift. We come from the introduction of KVM, one of the very original Linux-based hypervisors, and we've grown through that, through OpenStack, and then we've landed OpenShift virtualization, leveraging KVM and KubeVirt in 2020. This is 6-year-old technology. We're not talking about anything new. So you have the ability to trust what's there. You have the comfort knowing that this is not new technology. This is well-worn technology utilized and run by many, many large organizations. KubeVirt itself is very mature. One of the top 10 CNCF active projects, because virtualization is such a thing and it needs to be thought about in terms of the way cloud native works. There's over 200 companies contributing towards this, 60 releases. The intensity and the number of contributing companies, because there's the vision of the value that this brings, is increasing quite rapidly. Who uses it? It's not as if there's it's small companies out there. There are a number of very large names on this slide that should give you a little bit of comfort that it's not just us saying how powerful this is. It's not just us saying you should be using it. Here are a number of end users and vendors that have taken on and started to utilize, build upon, and drive out KubeVirt itself. A prime example, NVIDIA, a company I'm sure you've heard of, utilize it for their on-demand gaming cloud. As you can imagine, that puts a lot of stress on both clusters and the way things run. But 28 million users, 1,500 games across 100 countries, across 30 plus data centers. I repeat, a well-proven, well-worn path for your technology. Open hybrid cloud portability, what I really like to talk about here and what can bring you huge advantages. You need to be able to move apps to comply with new regulations, new rules. You need to be able to place things in the right place at the right time. And that's not just because of regulation, that's because of the fact you might have an outage somewhere, and we've got various other bits that's coming in, but more importantly, you don't always want to have permanently on environments. So you might develop in the cloud, and then when it goes to production, you might decide that you need to run it on-prem. You need the portability to be able to move it. So that could be on-prem. You could deploy it across 2 hyperscalers at the same time to give you that kind of super high availability, super resistance to any kind of outage. And you need to be able to automate this. We've talked about infrastructure as code for years. In the OpenShift world, we talk about GitOps and how things should be fully automated. You should be at a place where you're utilizing GitOps, so none of your teams ever need to physically get into your production clusters. It is fully automated, and it's just pulling the right things that you know have had checks and balances all in place. This allows your teams, your organization, to accelerate your delivery pipelines, to get your services out in front of customers far quicker than you ever could before, with the stability that they expect and that you demand from all of your applications when pushing them out into the public domain. But why? Avoid operational lock-in. That ability to land things where you need to can allow you to move to the right environment that you need. And there are various reasons why you might need to move things to different locations, be that cost pressures, be that security reasons, be the fear the feeling that your blast radius could be too much. Unifying VMs and containers. Like I said earlier, there's a lot of conversation, and I suspect you, your teams, your organization, and you as management are very much saying we need to be more cloud native. We need to look at this, but you've still got teams looking after 20-year-old VMs and 20-year-old applications that cannot necessarily be put into a container. Here you've got the opportunity to treat your virtual machines in the same way that you treat your containers, starting to apply the good practices that you would expect for cloud native delivery. Consistent day 2 operations. Whether it's a virtual machine or whether it's a container, you can utilize the same tooling to get the same consistent results. Lifestyle flexibility, how you move things up, where they sit within the cluster, how tightly they are, the blast radius, the segregation that we provide via namespaces, whether there's east-west communication between things or it has to go north-south. We can bring all of that to your VMs as much as your containers. Resilient and exit options. Keep your options open. Very much the mantra of right workload, right location, right time. If you want to build, dev, test on-prem and then ship into the cloud because it protects your on-prem environment, and that's where the customers need to access it. That makes sense. If you think that actually it needs to sit on-prem and it needs to be more protected through your guards that you've got there, then you can dev, test, build in a cloud environment that allows you to scale up and down to save you your cost. Flexibility, choices, business regulatory things, depending upon politics in the world, it once again brings you that level of flexibility. But then also platform team leverage. It's a big conversation that we also have, and it's how the fact that your infrastructure engineers and your SREs can build platforms that get out of the way for your development teams, allowing your development teams to pick up quickly, pick and choose what they need to do without having to fight for a long time to get things set up. But still, we're the infrastructure team, and more importantly, your security team, and then on top of that, your FinOps team, your finance team. The guardrails are there in place to allow this rapid development, the ability to experiment, but without breaking the budget, without breaking security, and without causing problems in your core infrastructure. Standardized tools, be it your first cluster or your 100th cluster. You can literally build this where you have a consistent management, consistent security, and a consistent container registry, but it doesn't matter where your cloud lives. Cloud A, Cloud B, and the way that once the cluster is built, the way that everything deploys on top of that is the same. One platform, one operational model, a standard way to deploy, observe, and secure all of your workloads, particularly your critical workloads. Options that we've got: IBM Cloud, Microsoft Azure, Google Cloud, Amazon Web Services, and then there's a whole plethora of environments that you can land should you want it on-prem. We have Red Hat OpenShift in IBM Cloud, Azure Red Hat OpenShift, and Red Hat OpenShift on AWS. They are native OpenShift, managed OpenShift services to those hyperscaler. And then we've got OpenShift Dedicated, which is once again a managed OpenShift offering that is run by Red Hat on the Google Cloud platform. How does it work? We've talked about consistency. We've talked about the ability to make sure everything is delivered in a unified way. One platform, one way, one delivery. Argo CD, the core of this. With Red Hat Advanced Cluster Manager, this is your single pane of glass that allows your engineering teams, your infrastructure teams, your platform teams to see exactly what is going on and where it's going on, be that on a ROSA cluster, be that on an OSD cluster, be that on an ARO cluster. You have the option to build your clusters however you want and import it in, or you can actually build the clusters utilizing ACM itself. But this ACM comes with all the policies you could want, the ability to control, to check, to make sure that your environment is aligning with the requirements that you need. We'll jump into a quick demo at this point. To help you understand how the technology of OpenShift virtualization can assist your engineering teams, your development teams, your infrastructure teams to deliver what you require in terms of value, the applications that your customers need to use, how you can get those out there, and how we can help you with OpenShift virtualization to allow you to land the workload in the right location at the right time based on your requirements. This cluster is running on Red Hat OpenShift on AWS. And on top of that, we've installed Advanced Cluster Manager. This provides your engineering teams, your infrastructure teams with the single pane of glass that gives them full visibility to their hybrid deployments. We are utilizing the cloud for this example simply because we can stand up servers there easier. This allows us to connect through. ACM, like I said, is that single pane of glass. You jump into here and you can immediately see the number of clusters that we've got. Like I said, This ACM is running on top of Red Hat OpenShift on AWS or ROSA. We also have another ROSA cluster. We also have an Azure Red Hat OpenShift cluster in Azure, and we also have an OpenShift dedicated running in Google. If you take a look what we have, you can see the clusters that we have in total, the versions that they're running on, the application types that are there. Are there any violations? No. Work accounts and all of that. Like I said, this is to speed up and to give the visibility to your engineering teams what they need to see straight away. As you would expect, it doesn't just allow you this high-level overview, but you have the ability to dig in, add more clusters, remove clusters, configure clusters, and things like that. We'll jump in and we'll take a quick look. Obviously, this dashboard now segregates out each cluster as it is there. See, there's an important bits on the top where you've got cluster lists, cluster set, cluster pools, and discovered clusters. And you have the ability to create a cluster or import clusters that you've already stood up else. We'll quickly jump into the ARO cluster. As you can see, the amount of information, things like labels, what version it's on, and all of that is here. You can also set the ability, the channels that your cluster is looking at, the ability to upgrade them and move them around to the versions that you want, and also initialize the actual upgrade should you want to. If we click on nodes, that gives you all of the virtual machines that are required to actually run the environment here. If you click onto one of those nodes, it'll immediately take you through to the cluster console. We'll just take a quick look at cluster sets. Cluster sets, like I said, allow you to define the boundaries around groups of clusters or stick clusters together in a group. In our case, we're looking at multi-cloud because that's what we're demonstrating, but this could be your production, non-production, pre-production environments, or your specialist AI environments. However you want to segregate them, however makes sense in the way that you want to apply controls and policies. If you click into your cluster set, it immediately brings up the list of clusters that are there, another high-level overview, cluster lists, your cluster pools. But more importantly, it pops up this something called Submariner add-ons. The way that we allow these clusters to communicate is through the utilization of Submariner. Submariner sets up IPsec VPN tunnels between the cluster that can expose the whole cluster down through services down to pod level. And obviously it's set up through IPsec because of the levels of security, but also the bandwidth that's required. So once again, allowing your teams to do what they need to do with the comfort of not be concerned about security as a whole, because it has been implemented for you as you would expect from Red Hat. Those two important buttons I mentioned, you need clusters to make it worthwhile having a cluster manager. We allow you to stand up clusters beforehand and then you can import them in. There are multiple ways to import them in manually or using the cluster API and the token. We also allow you to build clusters directly through this interface as well. And as you can see, there are a plethora of places. Once again, truly hybrid. You want to deploy it in AWS, you want to deploy it in ARO, you maybe even want to deploy it on OpenShift virtualization that runs on-prem. ACM brings you that opportunity, and we will work across all of those environments to deliver the applications, the virtual machines that you need to run. We'll quickly jump into the governance area. As mentioned, the ability for consistency and control over the clusters is very important, and this is where you can set that. One of the best ways to run environments these days is through GitOps, and we have the OpenShift GitOps operator. Now, for us to be able to demonstrate what we're going to do today, we need to install that. But just like any other operator or just like any other control you need to put in place, the governance and the policies are where you do that. We've defined that we want the GitOps operator to be installed on all of the clusters that we're using here. And you can define many different policies, and we'll demonstrate very shortly that there are templates there already for core things that we see customers use day in, day out. But if we just click through to the GitOps operator installation, you can see even more information down there. It comes with the steps that were required to implement the need or to install the GitOps operator, the messages that get brought back. But more importantly, as you can see, if there are any violations, they get highlighted very quickly. We'll jump into creating policies, and as you can see, once again, it's very much a form-based element. But as you click through, and as I just mentioned, is that you've got policy templates that are there and available directly out of the box for you to be able to use. Important things like enabling etcd encryption, to install the operators, to remove privileged pods so nothing runs as root, that role bindings must exist, and these will get pushed out to all of the clusters that are under this policy. We'll jump now to the application section. As you can see, there's a number of applications already installed. But if we click on the create application, you'll see this is where the importance of Argo CD comes in, where you have the choice to how you would deploy your application. Pull model is the better choice for security because it pulls it in from a repo. And as an engineer, I talk about security where people shouldn't have to touch production, because you've implemented these processes, you've built everything, it's infrastructure as code, it's applications as code, and you get to the point where you've marked off your repo and your containers in such a way that Argo CD can pick those up where needed in production, saving any human from having to interact with those environments. So as you can see, once again, form driven. Or you could implement the YAML yourself. We'll fill in the name that we want for the application set here, the Argo server that we're going to use, the time that we're willing to allow to set it up, and then we'll click Git because we don't want to use Helm, but we've got a repo already set up. And anybody that's utilized K8s in the past and OpenShift will know that this is just your bog standard GitOps practice. There is nothing here that we're doing any different that we would do for a container, yet we are deploying virtual machines and we're going to deploy them across the cluster. We'll fill in our sync policy. As I mentioned earlier, this is the way to make sure that you can deliver new VMs into your production environment, but you don't necessarily need to allow users to have direct access to that production environment. Here's the code just to prove it there. So it's a bunch of YAML files as we normally expect, but it is deploying our virtual machines instead of just the normal containers. But once again, VMs run within the containers. So we jump back in. We move on to the placement. We're going to select our multi-cloud cluster set that we talked about earlier. So as you know, this runs across AWS, Azure, and Google Cloud. You can set which ones you want to miss on, and we do not want it to run on the local cluster because the local cluster is still part of the multi-cloud bit, but we want it to run on the three others. So we do that, we hit next. As you can see, the review comes up and we hit the button. Let's confirm. Let's see what's happening in the background. So we'll dig into our cluster. We'll get the project namespace. We'll move into that. And we'll copy this across all three clusters that are running. So we can check that everything is consistent across all three. Then we get the VM name. We check that's running. We'll get the pod just to prove that the pod is here. And let's get the service because it's the service that we want to talk to be able to check that these machines are up and running correctly. So now we've got our external IP for each machine. Let's quickly jump in just to confirm that they've actually stood up based on the template we've got, and we're getting the information out of them that we need. As you can see, ISP is telling us that it's Microsoft, so therefore it's running on Azure, as you would expect. We'll jump into the next cluster, and there you go. As you can see, it's saying Google, how long it's been running for, RAM, CPU, once again. And then finally, we'll jump into Amazon. And as you can see, the ISP is Amazon. So there you go. You can see that utilizing the GitOps practices, we have been able to deploy virtual machines, the same virtual machine, across all environments. So we've proven the fact that you can stand up 3 machines very quickly. But you might be thinking, what value does that bring? Just give you a quick example here. You can obviously configure your networking then to be able to connect back to each of the instances from a single URL. And as you can see here, just by refreshing this page numerous times, it will pop up with the different machines running in the back end, therefore allowing you to be able to span all 3 clouds in this case, but deliver exactly the same application that you need to. A quick change to a new view, fleet virtualization. Obviously, virtualization has been around for some time, and the interface that virtualization admins have had available to them has been pretty much the same for a very long time. Red Hat has focused on and emphasized the ability for an easy transfer over for them to be able to use virtualization within Red Hat OpenShift. If you open the Fleet Virtualization interface, you will see how very similar it is to previous virtualization vendors, and where the clusters sit and all the different clusters you have and what is actually running in terms of virtual machines or stopped or paused or errored out across those clusters. And you are able to dig into each cluster individually to see where your virtual machines are sitting. As you can see through this interface, we have 3 different virtual machines, one on each of the hyperscaler clusters that we've got. Just to give you an idea, here is the one from Azure, here is the one from Google, and here is the one in AWS. We'll jump back in now, and we'll just pick the one that's currently based in Google, the OpenShift dedicated cluster. And if we right click on the 3 dots, you can see that it gives us a number of options, one of which is live migration. Migration brings us the choice of do you want to go to a different node within your cluster? But more excitingly, as you can see here, it gives you the option, once again, hybrid capability to migrate to a different cluster in a different location. And we're going to demonstrate lifting the VM from Google OpenShift and moving it across into Azure. As you can see, it quickly maps out all of the information that's required. So network mapping, storage mapping, compute, version capability, and you quickly hit the migrate button and it creates the migration plan. The migration plan is what enables the service to move live. As you can see, it's already at 33%. There's lots of details, the YAML in here, and all of that kind of information that you can see to see where it's going. Currently initialize, prepare the target, and it is moving across as we speak. We'll jump back in and have a watch to see what is happening to the VMs, and you can see that at this moment in time, it is still running in GCP, as you would expect, but it is waiting to get the migration connection in Azure. And then it immediately flips to the status of migrating. It will copy across the data that will allow it to be able to run in the new cluster. Depending upon the size of the VM can dictate how long this takes to migrate. As you can see, it took about 80 something seconds for it to be migrated across, for the data to be migrated across, and for the system to come up. It didn't immediately kill the instance in GCP because it had to check that the new virtual machine was up and running. But then as soon as it did, it was migrated, data and all, into the ARO cluster. As you can see, one is now stopped, whereas the same name is now up and running in a different cluster. we in the browser jump to a new IP address, the new IP address of this virtual machine, and you can now see that it is running on Azure, and that matches the IP address there, but it's still got the message that this was the cloud VM that was deployed on OpenShift dedicated in Google. The great thing about that live migration technology is it allows you to bring in your virtual machines from other environments. The key bit being that you want to make your moving away from other hypervisors as easy as possible. So we're going to take you through a quick example where we're going to migrate a machine off of VMware and move it into OpenShift using exactly the same technology. So we'll pick the cluster that we want to migrate. So now we know what it is, and then we'll jump back into the OpenShift console and we'll click creating a plan. As you saw, when you do the live migration, it created the plan automatically for you. We're going to do exactly the same here in this process. You fill in the information. So you have to put the input details of the virtual machine source, in this case vSphere, and where you want it to land on the OpenShift cluster, or whichever OpenShift cluster that you want it to land on, and also within the project namespace that you want it to go to. Once you've hooked in, it'll ask you which virtual machine do you want to migrate, so you can filter that by name, and it will then come up with the virtual machine that you want. Set up your networking. Work out your storage, where you want it to get from, where you want it to get to, and the secret that you need to get access, and then the type of migration you want to do. Cold migration is obviously one of the best because it will turn off the actual virtual machine and then make the copy and turn it back on, meaning that you will get exactly the same information on the other side. Review the information and click create. Just like we saw last time, you get the migration plan that's created, and that will bring all of the information together for the migration. And in this case, you can just click start to kick it off. Once again, you can track the migration progress and see what is happening within the cluster itself. And wait for the machine to become available. And there you go. As easy as the live migration, we have now lifted a virtual machine directly from vSphere and moved it onto OpenShift Virtualization, demonstrating how quickly it is for your teams to move away from your current hypervisor and land on OpenShift and manage it on OpenShift moving forward. So just to round off, a comprehensive platform for all of your workloads. If you want to modernize your applications, if you want to drive into your cloud native development, virtualization still there, still going to be needed for some time, but now you can align it with your ways, your thoughts, your processes that go to your cloud native development. But as you've just seen in the demo, that ability to actually leverage multiple cloud, multiple locations to move things, to test things, to allow you to integrate with what you need to. We also offer AI-enabled applications. OpenShift itself is an application platform, so there are other tools that you can layer on top. Much like ACM is an application that you can lay on top, we have the ability to integrate AI with it. But also then we talked earlier about the commercial off-the-shelf stuff, how there are some builders of that refuse to go to containers. You can still continue using that while sticking to what you need to deliver in terms of cloud native. So OpenShift, Managed OpenShift, brings you the ability to leverage security, leverage stability, leverage repeatability, while moving towards a cloud native way of working, while still being able to consistently deliver and support and deploy applications in VMs as you have been for many years. Also taking on the potential of repeating how you've been doing it for many years. I hope this has been of help to you. Hopefully this will help you understand the value that we bring of the hybrid cloud with virtualization and how that can actually help your teams to be able to deliver faster, better, and bring clearer value for you, your organizations, and more importantly, your customers. Thank you very much for your time.